Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video on the chapter of probability, where I will be solving some 3 multiple choice questions, question number 11, 9 and 6 from the supplementary book of MCQs by author R.D. Sharma. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma, where I primarily discuss about the key concepts and formulas required for problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 6 video, where I will be solving 3 questions, MCQ questions from the MCQ Practice book on the chapter of probability. Okay, so the first question is question number 11. It says 3 coins are tossed at the same time 800 times. The outcomes are given below. So 0 heads has occurred 120 times, 1 head occurred 20 times, and 2 heads occurred x times. So clearly these events, 0 heads, 1 head and 2 heads, these are all the elementary events of the experiment of tossing 3 coins at the same time. I think there is another, there will be another event, even though it is not given in this problem. So since 3 coins are tossed, I can also have 3 heads. So 3 heads, there should be another outcome, even though it is not given. 3 heads. Now the total number of times the 3 coins were tossed is 800 times. So if I consider that the frequency of 3 heads be y, then I must have the sum of all the frequencies should be equal to 800. Okay. Now it says if the probability of occurrence of 2 heads is 3i's that of all heads. Now all heads, so definitely when it is saying that the probability of occurrence of 2 heads is 3i's that of all heads, this clearly shows that the probability of occurrence of 2 heads as well as the probability of occurrence of all heads is greater than 0. Then we have to find the value of x. We Now, okay. So first of all, we could have easily, instead of taking a variable y for 3 heads, we could have easily find the frequency of 3 heads. It would be these 4 events. Let's say I am calling this events E1. E1 means that when a 3 coin is tossed at the same time, 0 heads show up. Similarly, let's say 1 head, I'm naming the event to be E1, E2, 2 heads to be E3, and 4 heads and 3 heads to be E4. Now all the frequencies, sum of all the frequencies should be equal to 800, because the 3 coins were tossed 800 times. So from here I will get y in terms of x. This will be 800 minus 400 minus x, which is 400 minus x. Okay. Now what is the probability of occurrence of 2 heads? 2 heads means I have named that event E3. So probability E3 will be equal to, using the empirical formula m by n, how many times the frequency of the event E3 is x by 800. Okay. And what is the probability of occurrence of all heads? That is 3 heads. All heads means 3 heads. It is probability of event E4. Using the empirical formula, it will be m is y, which is actually 400 minus x, divided by 800. Okay. Now it is given that probability of E3, that is probability of occurrence of two heads, is 3 that of all heads. So we are given probability of E3 is 3 times probability of E4. So this implies, what was probability of E3? Probability of E3 was x by 100, 800 is equal to 3 times probability of E4. Probability of E4 was 400 minus x divided by 800. Now I can cancel 800 from both the denominator, from the denominator of both the sides. So now this becomes x is equal to 3 times 400 minus x, which is a linear equation in x which can be easily solved. This implies x is equal to 1200 minus 3x. This implies 4x is equal to 1200, and this implies x is equal to 1200 divided by 400. Sorry, not 400 but 4, which is equal to 300. So the value of x is 300. So the correct choice is C. Let's see the next problem. Question number 9. So these questions are from the supplementary books of MCQs by the same author, R.D. Sharma, of class 9 mathematics, CBSE board. Question number 9 says, a bag contains 50 coins and each coin is marked from 51 to 100. One coin is picked at random. The probability that the number on the coin is not a prime number is. Okay, now, a bag contains 50 coins and each coin is marked from 51 to 100. One coin is picked at random. The probability that the number on the coin is not a prime number. So basically we need to know how many prime numbers are there between the numbers from the number 51 to 100, which I don't know. I mean, if I start counting, it will take some time. Let's see. So 51 to 100, let's say this is 50, 60, 70, 80. Okay, for 50, from 50 to 59, from 50 to 59, how many prime numbers are there? It will be basically, I think how many prime numbers are there between 0 to 9? We have 2, we have 3, we have 5, and we have 7. We have 7, but okay. So from 50 to 59, how many prime numbers are there? It should be similar, but 59 is also a prime number. So I think it will be 5. 5 primes are there, 5 prime numbers are there between 50 and 59. 5 primes. Similarly, from 60 to 69, oh no, 69 is not a prime number. Now I think I will waste time if I start counting what are the number of prime numbers between 51 to 100, and I have no knowledge if there is any formula. What is the prime number? What is the number of how many prime numbers are there between two given numbers A and B? In terms of A and B, I don't know. So the idea is that let's say how do we solve this problem? So the idea is let number of prime numbers between 51 and 100 be equal to m. Whatever this m is, you have to find this m. So now when a coin is selected from the bag, randomly, then what is the probability that the number on the coin is not a prime number? Is not a prime number. So from the number 51 to 100, how many numbers are there which is not prime? So this implies number of coins in the bag, number of coins in the bag that is not a prime number, that is not a prime number, should be equal to, now how many numbers are there, how many coins are there in the bag? The coins are marked from 51 to 100. 51 to 100, how many numbers are there? The formula is 100 minus 51 plus 1 which is equal to 50. So if you want to know how many numbers are there between two natural numbers a and b, that is including a and b, it will be b minus a plus 1. So the number of coins, total number of coins in the bag is 50, since the coins are marked from 51 to 100 sequentially, and we have assumed that out of these 50 coins, we have assumed that from the numbers 51 to 100 let there be m number of prime numbers. So quite obviously in the bag, how many coins will be which are not prime? It will be 50 minus m. So now so what is the probability? Let's say, okay, so what is the probability? Now for solving problems on probability, it is always advisable to solve it in a meaningful way. That is, you should name every event with some letters and then access the letters to find its probability. So let's say the event, I am naming the event E as randomly selected coin, from the bag is not a prime, number. That is, it is not marked by a number which is a prime. So randomly selected coin from the bag is not a prime number. Let this event be named E. So we have to find the probability of E. So probability of E will be how many cases, what is the frequency? What is the frequency of, if you consider these 50 coins to be to be 50 trials, then in how many number of trials we see it is favorable to the event E. That is, what is the basically what is we are using empirical formula. We know that the probability of event E will be m by n, where n is obviously the number of coins in the bag and small m is the number of coins in the bag which is marked with a number which is not a prime. So m is basically, we have found earlier, to be 50 minus m divided by n is 50. Now this small m, 50 minus m, this small m is the number of prime numbers between 51 and 100 which you have to find out. So this should be the answer. Because I don't know what m is, I don't know what the answer will be. Okay, the question has asked to find the probability that the number on the coin is not a prime number. Anyway, so to find all the numbers between 51 and 100 which is a prime, which is not a prime, for that you have to anyway know what are the prime. So I'm sorry I could not solve this problem completely because I don't know what will be the total number of, I need to know what will be the total number of prime numbers between 51 and 100, and then only I can find 50 minus m. So anyway, sorry for this. Let's see the next problem. Question number 6. A coin is tossed 1000 times. If the probability of getting a tail is 3 by 8, how many times head is obtained? We know how many times head is obtained. Okay, so we know that if a coin is tossed, if we consider the experiment, a coin is tossed, the possible outcomes are head or tail. Now let's say when a coin was tossed 1000 times, let's say the number of times head occurs is x, and the number of times tail occurs will obviously be 1000 minus x, because the sum of the frequencies of all the possible outcomes should always be equal to the number of trials. Okay, now from here, what will be the probability of head? Meaning, if a coin is tossed, then what is the probability that head will show up, or what is the probability of getting a head or getting a tail? So probability of getting a head will be based on the empirical formula x by 1000, and the probability of getting a tail will be equal to 1000 minus x divided by 1000 based on the empirical formula. Now in the question it is given the probability of getting a tail is 3 by 8. So we have probability of tail is 1000 minus x divided by 1000. This is given to be 3 by 8. So we can easily solve x from here. And once x is found, the problem has asked how many times head is obtained. So basically x is the number of times head is obtained that we have assumed. Okay, solving this, we have 8000 minus 8x is equal to 3000. This implies 8x is equal to 5000. This implies x is equal to 5000 divided by 8, which is equal to 42 no 86 48 6 to 5. So x is 6 to 5. And what is x? X is basically the number of times head was obtained. So the correct choice is C. Let's see the next problem. So there are no problems. Okay, so 3 problems. I'm really sorry that I could not completely solve the question number 9. If you know a way of easily finding out how many prime numbers are there between two given natural numbers, then please feel free to let me know in the comment section. I will highly appreciate that. I will also try to figure this out. So that is all for this video. I solved 3 problems from the MCQ Supplementary Practice Questions book of author R.D. Sharma from the chapter of probability. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.